Hey YouTube, this is RFX. Like my last video, I got another old school rack device to fix up. Or, well, fix is relative. This one actually does technically work, but there are a couple of things that aren't exactly as they should be. I'm talking about my Akai S3000XL Sampler. I just bought this thing recently for around 235 euros. About the cheapest one I could find that actually works. Usually they go for around 300 euros or more. Of course, with that kind of price, you can't expect it to be in perfect condition. So, what exactly is wrong with it? Well, the most obvious issue is the display. In its current state, it's kinda reminiscent of an old Game Boy. Just that it's rack mounted and you can't just move it around to find a better viewing angle. Of course, this is not how it should be. These old LCDs really don't age well, and there's two common issues that they will inevitably end up with as they age. One of them being bad contrast, where everything on the display looks washed out, no matter how far you turn up the contrast. Luckily, the contrast on my display is still fine. It's certainly not like new, but it shouldn't really be a problem. The other issue is the backlight. These old displays use something called an electroluminescent backlight, or EL backlight for short. They were very commonly used in old 90s devices like this. In fact, the WaveStation AD I fixed in my last video used the exact same type of backlight. There is one problem with them though. They suck. Compared to modern LED backlights, they're not all that bright and they're usually only rated for around 3,000 hours. Compare that to the 50,000 plus hours LED backlights are typically rated for, and you'll realize it's no surprise that the backlight on my S3000 is completely dead. It did work for a little bit after I got it, but it was so dim that it was completely useless, so I would have needed to fix it anyways. This is really the main thing I'm here to do, but there are two smaller issues with it as well. One of them being that the enter button is loose and jammed into the front panel. It's somehow still perfectly functional, although I would prefer it if the button was actually sticking out a bit like the other ones. The second issue is that the contrast knob is broken off. This also doesn't exactly harm the functionality of it, but it's a little annoying to adjust, so I'd like to replace it if possible. So let's just start by taking it apart. Luckily, all the issues have something to do with the front panel, so I really don't have to take it apart all that far. If you have a look around on the inside, it should be pretty clear why I'm happy about that. As far as the backlight replacement goes, the easiest and cheapest solution I found was to just grab another EL backlight. Full display replacements tend to cost over 100 euros, while just getting an EL backlight is a little over 20 euros. I still feel like that's a bit on the expensive side considering it's just a somewhat crappy backlight, but it doesn't break the bank either, so I guess I'll just deal with it. So in order to start fixing this thing, I need to remove the front panel. That means a bunch of screws up here and a bunch of screws on the bottom. I'm going to start with the bottom ones. I believe there is only one of them in there. I'm just going to make sure. Yeah, I'm not sure if there's supposed to be more than one, but apparently two are either missing or were never there in the first place. But looking at the marks there, I'm assuming they're missing. So I guess the previous owner has had this thing apart before. Now, if I remember this correctly, this should just pop off. Yeah, it looks like it's loose enough. And there we go. Oh my god, look at the inside of this thing. This is filthy. Oh yeah, and here's that button. Wonder what happened to that. Looks like it just sort of snapped off. Ah, well that's unfortunate. Okay, let's get to removing the display. This should be relatively simple. There's this wire going from the old backlight to the inverter that is right here. And it's zip tied in place. Let me just remove this. Careful not to snip any wires. There we go, that looks good. There we go, that is the backlight wire coming from the display. Next, I'm gonna need to unplug this. This is kind of hard to get on camera because the connector is like behind the display, but here it is. That is the data connector for the display. And now that we got that out, let's just remove it. Should be simple enough. Alright, I might need to catch this thing once I remove the final screw. Make sure it doesn't fall. Here's the display. And there it is. So regarding that backlight, this should be relatively simple. Well, guess who's back at the soldering iron? You just know that nothing could possibly go wrong here, right? basically what I'm gonna need to do, this right here, this little sheet looking thing is the backlight in there. And I'm gonna need to just desolder it from one of these points here and, well, get the old one out, put the new one in, and that should be all I need to do. Really simple enough. This thing works again, as you can see. Okay, got that one off, or not. Now that should be off. There we go. That right here is the old backlight. As you can see, it looks pretty similar. Both of them are pretty much the same kind of backlight. You just slide it in behind the screen and these two pins are then connected to the pins right back here. And I'm gonna need to solder this wire back on too. So let's put this old one aside and get the new one out of here. Now you just take this and slide it right in here. Very easy, as you can see. I'm just gonna have it stick out a little bit like that. Bend these pins over to the other side. Now, the polarity on these things is not important because they run on alternating current, so I should start by just tacking this on very roughly. Guess what? I also remembered to change the soldering tip. There we go. That's a very rough solder joint, but it doesn't need to be perfect right now. I'll clean these up later. Okay, that's pretty much in there. Alright, what I also forgot to mention is you gotta make sure that the pink side faces forward. In my case, it did. Like on the back, this stuff is blue, but yeah, just so you know. Now there are two pads for both of these sides. I wonder if there's continuity between them. I will make the assumption that they're supposed to be together. So I'm pretty sure the inner ones and the outer ones are the same. Let me just tape these contacts down to clean up the solder joints. Get my children's scissors out. That should hold it down long enough for me to add some solder. I'd say those are pretty good solder joints, right? Now I can take off this tape. Alright, tape. So now it's just a matter of soldering the wire back on. The orientation here does not matter because, again, this is AC. Let's pre-tin the wires a bit. Now I just need to put these on here. And there we go. I'm just gonna go and clean this up a little bit under the microscope to make sure I get everything. The solder joints look pretty good, I would say. Now we just clean this up as good as we can. It'll be a little bit hard to get in between these two solder joints, but oh well. And this right here is why you clean PCBs after you solder to them. There's all this shit building up. Time to test the backlight. Let me just put the wire back through here. The wire's sort of in the way now. I think I'm gonna need to bend these a little bit. There we go, like that. Now we put some screws in. There we go, all the screws are in. Now let's plug everything back in. This is the backlight connector and the data connector right here. Again, this is going to be a bit tricky to see. And yeah, that's the backlight replaced. Let's just see if it actually works. Let me grab a power lead. Of course, make sure you don't touch any of the live wires as you plug this in, otherwise you might die a little bit. Okay, moment of truth. Does the backlight work? Well, we gotta turn it on first, I think. Oh, look at that. You can actually see stuff now. Look at that. Wow, that is a lot better. But yeah, the backlight's working perfectly fine, so that part of the problem is fixed. Well, that went surprisingly smoothly. Turns out replacing the backlight of an S3000 is quite easy if you know how to do it. The other two issues are going to require a bit of creativity though. Let's focus on the enter button first. As you saw earlier, it was completely loose, which it really shouldn't be. Usually there would be two little plastic tabs on there that connected to the button assembly. Those have broken off though. Considering how tiny these are, I doubt I could glue it back on there without making a complete mess. Unfortunately, replacements are not being sold anymore either, but I do have a plan B of sorts. And that plan B is to just 3D print some replacement parts. You know, I quite like 3D printers. They allow you to pretty much take anything you have in your mind and turn it into a piece of plastic. Very convenient, not just for repairs, but for all sorts of DIY projects as well. Of course, I won't be able to make a perfect replica of the original button, but that's not really what I'm trying to do here anyways. I just want the button to feel like a proper button again, instead of some random piece of plastic jammed into the case. In order to make a replica, I started out by taking some measurements and writing them down. I was mostly interested in the size of the hole left by the button and the dimensions of the button itself. I just used some digital calipers to take these measurements. They don't really need to be super accurate. If something doesn't fit, I can always tweak the design later. Here are the measurements I ended up with in case you're interested. Regarding the design, I'll be using Fusion 360 to make a replacement for the button. Should be pretty simple, really. I started off by creating a little box that matches the dimension of the button housings. After that, I put another box on top of it that matches the dimensions of the button that will stick out of the case. I then tried to roughly match the chamfer on the original button. It's not perfect, but it'll probably do the job. To finish it off, I just added some rounded edges at the connecting point to make it a little stronger, and I also rounded the base of the button. And that's pretty much all I need to do. This is what the finished button looks like. In order to print it, I just need to run this through a slicer. I personally use Cura for this. I already have all my settings set up for the material I'm going to use, so all that's left to do now is load it onto my print server, preheat my printer, and start the print. While the new button was printing, I decided to carefully break off the plastic tabs meant for holding in the old button. This is necessary to fit the new one, since it's pretty much just a solid block that uses the button housing to keep itself in position. The print was done in about 10 minutes, and after removing it from the print bed, I tried it out right away. It fit into the housing perfectly fine, and I was able to activate the switch underneath it. However, after trying it with the front panel on, I found the button to feel a bit loose, and I wanted to improve it. To do that, I pretty much just needed a slightly tighter fit, so I simply increased the size of the base a little bit and printed it again. Since this is a really small print, I can essentially just try over and over again until I get it just right. Printing something this small costs almost nothing, and it only takes a few minutes to do. That's pretty convenient since this one turned out to be just a tiny bit too large to fit. In the end, it took me a total of 4 attempts to get it just right, but with my final revision, the button is sitting in there really well and barely moves around. I'd call that a success. You might be wondering why I didn't even try to match the original color of the button though. My reason for that is the simple fact that I will most likely not find any 3D printing filament that matches the original color perfectly. And besides, the different texture of the 3D printed material is still going to stand out, even if I somehow manage to match the original color perfectly. That's why I decided to simply go for something completely different. That way it will look more like a cool mod or customization rather than a janky repair. I quite like the way it looks, but let me know what you think in the comments below. Now that the button is fixed, there's only the contrast knob left. To be honest, this is also not really a big issue, but it would be nice to have a knob that you can properly hold rather than one that you have to awkwardly nudge. The process for this is pretty similar to what I did for the button, although in this case I'll need to make sure the marking I put on the knob matches up with the label on the front panel of the sampler. I started by creating a hollow cylinder to go around the shaft of the knob. On top of that, I put a slightly larger solid cylinder that will act as the actual knob you grab onto. This created a little overhang, so I put a chamfer on the connecting edge of the two cylinders. This will help make the part come out a bit cleaner, as 90-degree overhangs don't print well, even with support material. Now, the original knob uses a bunch of tiny teeth to grab onto the potentiometer. I likely won't be able to get teeth this precise to work well on my 3D printer, so I decided to put a little bar in there instead. This is going to go into the slot in the middle of the potentiometer and grip onto it like that. Afterwards, I added a little cutout on top to serve as the indicator that shows you what position the knob is currently set to. To make it look more interesting, I also added a little pattern to the edge of the knob by creating a bunch of cylinders around it and then using that as a stencil to make a bunch of little cutouts in the knob. This will give the knob some extra grip too. I also smoothed out the top edge a little bit, and that's the replacement knob design finished. This is what it looks like. Now on to printing. Unfortunately, my first print ended up failing because the part came loose during printing, but that's okay. It printed just far enough for me to test if it fits. Turns out the bar in the middle was a little bit too thick, so this one would have ended up in the garbage anyways. So I made the bar a little bit thinner and tried again. Just that this time I changed my slicer settings to print the knob with a brim instead of a skirt. This should be enough to prevent it from coming off during printing. The print worked fine this time, but the bar in the middle of the shaft was still a bit too thick. I also checked how accurate my marking was and, well, I'm not sure what I was expecting considering my very questionable method of figuring out the angle. Needless to say, it was about as far off as it could possibly be. On top of that, I also tested if it would fit through the hole in the front panel. Turns out I even screwed up that part. It honestly looks like I made every single mistake I could have possibly made, so I had to go back and change several things. Aside from obviously making the bar thinner again, I decided to do the alignment of the marker properly this time by just importing some pictures of the potentiometer and the front panel into Fusion. That way I could pretty easily align it by eye. I also found the marker to be a little small for my taste, so I made it just a little bit larger. I also decided to ditch the larger cylinder on top and just made that one the same size as the bottom part of the knob. After printing this one, it at least fit through the hole in the front panel, but I still couldn't fit it on the potentiometer since the hole I made in the bottom is too small, so I had to change it yet again. This time it actually fit, but it was really wobbly, so I guess I overdid it a little. I also noticed that the marker still didn't line up perfectly with the scale on the front panel, but it was pretty close. At this point, it's just a matter of fine-tuning the design to be exactly as I want it to be. After another revision, I realized why I originally had trouble fitting the knob on the potentiometer. I have a very slight elephant's foot on my print. I can't really see it with the naked eye, but it's clearly enough to make fitting the knob more difficult while at the same time making it wiggle around when it's fully on. Now, I could do it the proper way and fine-tune my bed leveling, but I could also just do it the lazy way and just make the knob a little shorter. Well, who would have guessed the stupid way wouldn't work? Of course it would still wobble. So, did I finally decide to level my bed properly? Of course not. I just printed the knob upside down so the elephant's foot would be on the other side. That way, I could also switch back to using a skirt instead of a brim because there would be more material to stick to the bed during printing. Doing this made the bottom come out a lot cleaner, and it also made me realize how loose of a fit it actually is. So I made yet another revision, and through some sort of miracle, this one turned out to fit pretty much perfectly. Any remaining wiggle you see here is actually coming from the potentiometer itself, not the knob. This seriously took me 8 attempts to get just right. Some people might be a bit annoyed at seeing me screw up so many times, but I think it's important to show that things don't always go as smoothly as video editing can make them seem. Of course, I could have boiled all this down to, and then I 3D printed a replacement knob, but that would have been a little dishonest, don't you think? Anyways, to finish it off, I wanted to paint the little marker area of the knob in white. To do this, I put a little bit of acrylic paint on a thin piece of metal and applied it to the marker area with the help of a microscope. I'd say that worked pretty well. Alright, I finally fixed everything I wanted to fix on this thing, so now all that's really left to do is just putting it back together, so let's just do that real quick. Shouldn't be too hard. Let's put the front panel back on and put the screws in there. Let's not forget that screw in the bottom. Should be like here. Now I just gotta put the top cover back on. And yes, I know there's some rust on there, but honestly, I have no idea how to remove it, and quite frankly, I won't see it when it's inside the rack anyway, so I'm choosing to just ignore this. And I should probably unplug it while I work on this. Let's screw this in and probably put this on properly. That would also help. All right, there we go. That's the sampler all fixed up now. As you can see, the contrast knob aligns with the markings pretty much perfectly. So now we actually have a knob that you can turn. Let's just give this thing one final test. And boom, look at that. That is nice, isn't it? This button is nice and clicky. This knob
Moves about as much as the potentiometer. There's not any extra wiggle room from the knob itself, so I'd call that a success. Now I just need to put it back in the rack.
Well, that was certainly something. I really didn't expect the knob to take this many attempts. Either way, this is going to make the sampler much nicer to use from now on. Of course, I'm well aware that my fixes for the button and the knob aren't true to how it originally came from the factory, but that's not really what I was trying to do anyways. This was more about improving the usability rather than a proper restoration. I do plan on using this thing after all. Sourcing original replacements for the plastic parts would have been very difficult, if not impossible anyways, so I think that this is the next best thing I could have done. Also, just in case anyone else needs them, I'll be uploading the STL files for the 3D printed parts I made. You can find the link in the video description down below. Now, I would give you a demo of the S3000 like I did for the Wave Station in my last video, but there really aren't any sounds to show off. I mean, this is just a sampler, so it doesn't actually come with any factory sounds besides some basic waveforms. There are some sample CDs that have been uploaded to archive.org, but I can't load them since I don't own a SCSI CD-ROM drive. However, I do have an idea on how I can show this thing off, but that will be its own video. Most likely the next one I'll upload after this. I won't tell you exactly what it's going to be about just yet, but it will involve me using the sampler to make some music. If you're interested in seeing that, then you know what to do. But either way, that'll be it for this repair. I hope you enjoyed it, and I'll see you in another video.